Save on Energy presents energy-saving strategies for ventilation systems. Welcome back. In Part 1, we explored how ventilation systems work in multi-unit residential buildings. In this video, we'll dive into practical no- and low-cost strategies that'll help you optimize these systems to save energy, improve indoor air quality, and reduce operating costs. Let's look at 6 proven ways to make your ventilation system more efficient, starting with adjusting ventilation rates. Adjusting ventilation rates is one of the most effective ways to conserve energy while maintaining air quality. Here's how to do it in buildings with multi-speed supply fans. Lower ventilation during unoccupied periods, such as overnight or during the workday. It'll cost you nothing. Or consider low-cost solutions like programming fan schedules or using occupancy sensors to adjust ventilation automatically. In buildings with single-speed supply fans, consider installing a variable frequency drive or VFD. It'll allow fans to adjust automatically based on occupancy schedules or sensors. Did you know, thanks to fan affinity laws, even a small reduction in fan speed can lead to big energy savings without compromising fresh air? Adjusting ventilation rates lowers energy use, reduces fan wear and tear, and maintains air quality. Dirty filters restrict airflow and force fans to work harder to maintain the required flow. This increases energy use, worsens indoor air quality, causes equipment wear and tear, and drives up maintenance costs. That's why it's important to check filters regularly and clean or replace them as needed. A regular replacement schedule, typically every 1 to 3 months, goes a long way. A low-cost solution, like using high-efficiency filters with a low pressure drop, will also have a significant impact on system performance and energy efficiency. Air intakes can get blocked by debris, leaves, and/or snow. This reduces airflow and energy efficiency. To maintain proper airflow in your building, keep air intakes and exhausts clear of obstructions, or at a low cost, add vent and grill inspections to your seasonal maintenance routine. These no- and low-cost solutions will also have the added benefit of improving resident comfort. This video focuses on ventilation systems with centralized supply and decentralized exhaust, commonly found in existing multi-unit residential buildings, but let's also take some time to talk about energy recovery ventilators, or ERVs, and heat recovery ventilators, also known as HRVs. ERVs and HRVs are advanced systems used in buildings with both centralized supply and centralized exhaust, or fully decentralized systems. They're most effective in new or upgraded buildings with tighter envelopes. Did you know ERVs and HRVs can recover up to 80% of the heat from exhaust air, saving energy and improving year-round comfort? ERVs transfer heat and moisture between exhaust and incoming air streams, helping control indoor humidity levels. HRVs transfer heat only, recovering warmth from outgoing air to precondition incoming air during colder seasons. Even though they may not be suitable for all buildings, these systems are worth considering in retrofits or new construction for their high efficiency and comfort benefits. Consider evaluating your building envelope and system configuration to determine if ERV or HRV integration is feasible in future upgrades. If your building already has a ventilation system with both centralized supply and exhaust, retrofitting an HRV or ERV into existing ductwork will significantly enhance energy efficiency. Did you know leaky or poorly insulated ducts can waste 20 to 30% of the conditioned air a ventilation system produces? It costs nothing to regularly check for signs of leaks like dust trails, drafts, or uneven airflow. At a low cost, you can seal duct joints with mastic or foil tape and insulate ducts in unconditioned spaces. This will improve resident comfort, boost energy efficiency, and ensure that fresh air is delivered as intended. Did you know smart ventilation systems can reduce energy use by 10 to 20% without compromising air quality? They respond to changing conditions in real time. Let's go through some common use cases. Carbon dioxide sensors detect occupancy levels and increase fresh air intake as needed. Smart thermostats coordinate ventilation with heating and cooling for seamless comfort and savings. Building automation systems track indoor air quality and adjust ventilation to ensure optimal performance and comfort. In your building, you can activate any existing smart features like scheduled ventilation or demand-based controls. At a low cost, you can install carbon dioxide sensors or link ventilation systems to a smart thermostat or building automation systems. With these strategies, your ventilation system will respond to residents' needs in real time, improving their comfort while reducing energy use. A well-optimized ventilation system does more than circulate air. It supports resident health and lowers energy costs. By implementing simple, cost-effective strategies, you can create living spaces that are healthier, more comfortable, and energy efficient. Thanks for watching. Let's keep making our buildings more sustainable, one breath at a time.